So good morning class. Today we are going to start chapter 2 of class 12 NCERT, which is electrochemistry. So what we are going to do, we will start this chapter from the scratch and from the basic. Then we will go to the main level. Then we will go to the advanced level for our exam for August. So let us start with the basic definition of this chapter. So the first question should be, as we are starting this chapter from the basic. So first question should be, what is electrochemistry? Before discussing this question, I want to tell you that this whole chapter basically is based on a simple statement, which is that energy neither is created nor be destroyed, but it can transfer from one form to another. So basically this whole chapter is based on the statement that energy can be transferred from one form to another. So this whole chapter is based on basically energy conversion. Okay. So now the question should be, what kind of energy conversion we are talking about? Because there are many kinds of energy. For example, electrical energy, hydro energy, mechanical energy, static energy, potential energy, kinetic energy. So what kind of energy conversion we are talking about here is, to discuss this, let us discuss this next. The name of chapter is electrochemistry. If we divide this term into two subunits, so here electro means electrical energy and chemistry means chemical energy. So in this whole chapter we will discuss about electrical energy to chemical energy conversion and chemical energy to electrical energy. This whole chapter is based on this basic statement that how can we change electrical energy to chemical energy and chemical energy to electrical energy. Okay? So the branch of chemistry which deals with the study of this basic conversion is known as electrochemistry. Okay? So now, to make this chapter easier and more understanding, let us categorize this chapter into three subparts, which are, first one is electrolytic cell, then galvanic or Daniel cell, and the third and final one is conduction and solution. So we are going to learn this chapter in three subparts to make it easier and more understanding. So let's classify this chapter in three subparts. So let us start with the first topic, which is electrolytic cell. So we are going to start with the basic of this cell. Okay. So there are three basic points to understand the whole topic. So the three basic points are that this is the cell which converts electrical energy into chemical energy. The second point is, this system performs non-spontaneous reactions. And the third and final one is, the value of delta G for the system is always positive. So let us understand these points individually. So the first point says that electrolytic cells converts electrical energy into chemical energy, which means we provide electrical electrical energy in the form of electric current to the system, which is electrolytic cell here, and with the use of this electric current or electrical energy, system performs chemical reactions and produces chemical energy. So, electrolytic cell is a system which performs chemical energy by the use of electric current or electrical energy. Okay? So, first point is clear. Now, second point, that the reaction performed by electrolytic cell is always non-spontaneous. Now, what is non-spontaneous? Let us learn this thing. There are two types of reactions, basically, which is spontaneous and non-spontaneous. Spontaneous are those reactions which do not require any external source of energy for the completion of reactions. But non-spontaneous are those reactions which require external source of energy for the completion of reaction. And as we see, for the chemical reaction or chemical energy production, we use electrical energy in electrolytic cell. That means electrolytic cell performs all the chemical reaction with the help of electrical energy. That means electrolytic cell is using external source for the completion of reaction. That's why it performs non-spontaneous reaction. Okay? So the third point is the value of delta G is positive. So here delta means change. Change can be positive or negative. Now G represents here gives free energy. Now the question is, what is Gibbs free energy? Because we are discussing everything from the basic. So Gibbs free energy is defined as minimum available energy of the system. So this is not the energy what we are providing to the system. It is the energy what system already experienced by itself. Okay? So the minimum available energy of the system is known as Gibbs free energy. Now we understand what delta represents here, what G represents here, but why the value of delta G is positive here? Let us discuss. For example, let us have a system X, okay, and it has minimum available energy of 100 joule. It is the minimum available energy, which is known as Gibbs free energy. As we discussed earlier, electrolytic cell performs only non-spontaneous reactions. That means it requires external source of energy for the completion of reaction. That means it is not going to use its own minimum available energy. If this amount of energy is not used, that means it will remain stored. So electrolytic cell do not going to use its own energy, minimum available energy, and is taking energy from the electrical source in the form of electric current. Let us take 15 joule of energy is given to the system. So the net change is 115 joule. So because system is performing non-spontaneous reaction and system is not going to use its minimum available energy, which is Gibbs free energy. So that's why the value of delta G is positive. So remember that always, whenever in any system non-spontaneous reaction occurs, so the value of delta G is going to be always positive. Let us learn with a very good example. Remember that For example, let us take a path that we are going on track. Okay, so there is a uphill path and downhill path. Okay, so whenever we travel to the uphill path, this path is going to be a spontaneous reaction, and downhill path is always going to be a non-spontaneous reaction. So if this is a point A, this is a point B, and this is point C. So from B to C, system is not going to use its own energy to travel this path, because we are going by ourselves, by the use of gravity. So we are not going to use our own energy. That's why the value of delta G will be positive here and value of delta G will be negative here. Because to travel or to reach from A to B, we have to use our own energy. Okay? So in case of electrolytic cell, the value of delta G will be positive because it performs only non-spontaneous reactions. So now we have all the information about the basic of electrolytic cell as we discussed earlier. So now we know that what kind of reaction it performs, what is the basic function of electrolytic cell. Okay, so now we are going to discuss the structure or construction part. So to prepare the electrolytic cell, first take the container and fill it with the solution of electrolytes. Basically, we are going to take electrolytic solution. Okay, let us take an example of NaCl solution. First, we convert solid NaCl into liquid NaCl by the heat. So it is the molten electrolytic solution of NaCl. So what is the electrolytic solution? Basically, it is the solution of electrolytes. And electrolytes are those substances which converts into its constituent ion in the presence of current. So for example, NaCl is going to convert in the presence of electricity into Na plus and Cl minus. So if we have NaCl solution here, so we have Na plus and Cl minus. As we know, we have to provide electric current as we are discussing the electrolytic cell. So we require metallic rod connected by a battery. These metallic rods are known as electrodes. For standard condition, we use platinum to make electrode because it is inert. Okay, so it is not going to react with the solution. Okay, and now what happens? So the basic process is the ions get neutralized on electrode. So let us learn how we write the reaction of the electrodes. At positive terminal, just remember once we want to write a reaction that we have to neutralize Na plus and Cl minus. Okay, so at positive terminal, which is going to attract obviously Cl negative. So Cl is in negative charged state. To make it neutral, it has to release electron. So the basic thing is, or basic trick is, you have to write the number of electrons equal to the charge. So it is -1. So write one electron on the right hand side and make it neutral. Now the question is, why Cl2 is written? Because on left hand side there is one Cl minus only. But Cl in neutral form can't be exist individually. So it is always exists in a combined state. Okay? So for balancing the equation, what we are going to do? We are going to half it. Okay, so reaction is balanced now. At negative terminal, obviously, Na plus going to attract. So to make it neutral, we have to add one electron. So when we are showing release of electron direction, we write always on right hand side. And when we show addition of electron, so we always write electron on left hand side of the reaction. Okay? So these are going to the reaction. So at negative terminal, sodium is formed. At positive terminal, Cl2 is formed. Now we have to select that which electrode is considered as cathode and which one is considered as anode. So remember that loss of electron means oxidation, and the terminal at which oxidation occurs is known as anode. Okay, so in this reaction there is a loss of electron. When we show loss of electron in a reaction, we always write the electron on the right hand side. So right hand side electron means loss of electron, it means oxidation, that means positive terminal in electrolyte itself is considered as anode. And gain of electron means reduction, and a terminal at which reduction occurs is cathode. So where the gain of electron occurs? So negative terminal in electrolytic cell is considered as cathode. Okay? So this is the way how we identify cathode and anode. Okay? So whenever oxidation occurs, that terminal is known as anode, and whenever the reduction occurs, that electrode is known as cathode. So let us recall all the topics we have done earlier. So now we know that electrolytic cell converts electrical energy to chemical energy. Value of delta G is positive because it performs non-spontaneous reactions, and positive terminal of electrolytic cell is anode, negative terminal is cathode, and anode is the terminal on which oxidation occurs, which means loss of electrons. And negative terminal is considered as cathode, terminal at which reduction occurs, which means gain of electron. So these are the points we have discussed earlier. So now what we are going to do, now we know how to write a reaction, and now we know what kind of reaction it performs. So we are going to do now, the topic is qualitative analysis. Basically, qualitative analysis is the topic where we identify that what are the products formed at the cathode and anode. Okay? So, case 1, if the solution is in molten state, okay? So, let us take an example. NaCl. Okay? Initially it is designed in a solid form. We heat and it is converted into NaCl liquid form, melted. So there is no impurity of any other substances. So on the passing of current, we have only Na plus and Cl minus. No gravity of any other solution. So now how to write the reaction? We have two ions, Na plus and Cl minus. So let us split. Add the electron equal to the positive charge on the left hand side and neutralize the substance. So here gain of electron occurs, which means reduction, and reduction occurs always at cathode. So at cathode, sodium is formed. For the Cl minus, write the electron equal to the negative charge on the right hand side of the reaction and neutralize it. Hence, chlorine, in the case of neutral state, it is always present in a combined state. So, to balance this reaction, we will add half here. Okay? So now, what happens here? There is a loss of electron. Loss of electron means oxidation, and oxidation occurs at anode. So at anode, chlorine is formed. So this is the reaction for the qualitative analysis, where we analyze what are the products formed at cathode and anode. Okay? So let us take another example. For example, now we have HCl. Okay? Or let's take another example, we have MgCl. So after the breakdown, we will have Mg plus 2 and 2 chloride ion. Now we have Mg plus 2 and 2 chloride ion. So as I said earlier, for the reaction of positive ion, write the number of electrons equal to the positive charge at the left hand side and neutralize the ion. So here gain of electron occurs, means reduction, means cathode. So here magnesium is formed at the cathode. For the negative charge ion, write the number of electrons equal to the negative charge. So it is minus 2. So write 2 electrons at the right hand side and neutralize. So there is no need to add half, because the number of chlorine atoms is equal both the sides. So here loss of electron occurs. Loss of electrons means oxidation, and oxidation occurs at anode. So at anode, chlorine is formed. So this is the way how to identify the products at cathode and anode. And this topic is very important for exam point of view. Okay?